Welcome to the Flange to CNC tutorial. We're going to cover some best practices for modeling, talk about parameters and how to use them, and then we'll talk about the computer-aided manufacturing, the CAM setup of how to do tool pathing for the CNC router. So we'll start with best practices. If we take a look at the rover from 2016, and we look down here at the timeline along the bottom, there are dozens upon dozens of sketches and extrusions, and trying to track down which part of the rover these go to make an adjustment would be really difficult. If we click on the sketches up here, same thing. There's a ton of sketches, and trying to find the right one to edit those is a really big challenge. That's all we knew when we first started CAD, but now we know some better ways. So best practice now is, instead of just start clicking on sketch and starting to go ahead and design, is you want to right click and select new component. That will activate that component, and then anything I do will be inside of this component tree. So now I can go ahead, create my sketch. I'll select my sketch plane. I'm going to start with a center diameter circle. I'm going to start with the second one. I'm also going to need a rectangle to be part of my flange. So I'll go ahead and do that. The next thing I'm going to add is I want this flange to kind of be centered on that dot, the center of my circle, so it's not off center at all. Easiest way to do that is to create a sketch point. And if I slide along the bottom edge of this rectangle, that whenever I get to the middle, that triangle appears, and that triangle means I'm at the midpoint of that line. So I hit OK. So now there's a little point at the midpoint. So now I can take this rectangle, and it doesn't matter what I do to the size or shape of that rectangle, that dot always stays at the center. So now I can take this dot, put it on the center, and once again, if I decide to adjust the size of my flange, it's always going to stay centered on my origin. I'll go ahead and add 2 more circles. I want these to be on that line as well. And right now, that's all the geometry that we're going to need for our flange. Everything else will be dimensions and patterns. So we come in here, and normally we start applying dimensions to the different parts of our rover, whatever part you're making. The correct dimensions are going to be listed in the PDF. You can see all of these are going to be diameter dimensions with a line through it. That means it's a diameter. So you can find the diameter for the center, diameter for the outside. There's a couple different ways to do the distance measurements. All 3 of these are based off of the center line. These 3 dimensions are from one to the next to the next. This first dimension, the 4.732, is the same in both, but then these dimensions, the 3 and the 1.25, are a little bit cleaner than these dimensions. So we'll use this method in our model. So if you have any questions on what the real values are, you can come back to this PDF and put them in. I'm just going to put in some random numbers because it will illustrate my point later on how it's easy to change these. You can see some of these things are, this circle is white. As I start defining some of these other measurements, I'm actually not going to do the full length. I'm going to do I want to define the width of this thing, and then I'm going to go from the distance from the center, grab the dimension tool. It is being really difficult. There we go. Define that dimension from here to that circle. define that one, and then from the edge to here. And those aren't the correct dimensions, but we can go back in and change. So right now those are all white, so they're all defined. There's no constraint on where this circle is, so I could, in theory, move this circle sideways. I haven't located where this circle is. It's not actually on that line yet. So I'll go in here. That's just the axis, it's not an actual line. So same thing, I'll go from the midpoint here down to the midpoint there. And I don't want that to be a real line that's going to kind of change the geometry. I want this to be a construction line. And now as a construction line, I can come in here and move that circle. It should snap to that construction line. And same thing with this one. I want it to be coincident, so I want this dot on that line. So now it's in the correct place, and if I click off, it's white because it's constrained. I'll move this one sideways. Coincident, I want this dot on that line. And now it's constrained as well. So everything in my sketch is now white, and that means that all those dimensions are constrained. That means they're defined somewhere. Next thing we want to do is we want to create a circular pattern. So I can select the objects I want. I want the top, both sides of my rectangle, and the bottom part of my rectangle. And then I also want to pattern those two holes. The center point will be the center point down here. And you can say that I've got a 3 in there for 3 flanges. You can change it to 4, 5, or 6, but our flange has 3. We'll hit OK. So that's the basic shape of our flange. And if we want to change some of these numbers, we can come in here and change them. And that's typically how we've done things. Normally we would come out here to our profile, start selecting some of these geometries. I'm holding down Shift while I select to get all those geometries, everything except the holes. And then I can just right click, extrude, and bring this out whatever distance, whatever thickness our flange is. And that's normally how we would start doing things. We can put a fillet on the edge here to make it nice and smooth. But what we're going to do different this time is we're going to talk about parameters. I can always come in here to my sketch, edit the sketch, and then change these numbers. But what we're going to do is we're going to come up here to where it says Modify, to where it says Change Parameters, and we're going to create some user parameters. I'm going to click on the plus sign. The first parameter I want to do is the diameter of that center hole right there. So I'm going to say diameter CH of the center hole. It's going to be in inches, and now I'm going to put in a certain number. Can't remember if that's it. I think so, but we'll go ahead and hit OK. And now that that's a variable I can use later on. I'm going to put another diameter, and this is the holes right here in the flange. So the diameter of the holes on the flange. Once again, I'm not sure what those are, so I'll just guess at a number. I'm going to say OK. We'll put some distances in here. I want the distance of the flange. We'll say the distance from the center hole to the first hole. Okay, and that's a little bit awkward. Distance, but center hole to flange hole. And that's some number. It's on the PDF. I can't remember what it is, but we'll go ahead and we'll put in those numbers. I'm going to add another distance. This is from the first hole to the second hole. That's some number. I'm going to say OK. Distance from the second hole to the end of the flange. And that's a number. So I'm creating all these parameters in here. I'm going to hit OK. And then now I'm going to come in here to my dimensions. And this 0.05, that's the diameter of my center hole. So I'm going to come in here, I'm going to start typing, and as soon as I enter the letter D, it brings up all those parameters that I entered. So that's the diameter of my center hole. I'll hit enter, and now it says this is a function. This depends upon what I entered into the parameter table. So same thing, I'll come here, double click that, enter D, and that's the diameter of the holes that are on the flange. So you got to make your variables descriptive enough that you can understand what you wrote. All the diameters are diameters of holes. So now those are both based upon the same function, even though they're different holes. If I come in here to change my parameters, if I change that from a 0.3 to a 0.5, then both of those numbers change to a 0.5. I can hit OK. I don't have to worry about trying to find both of these or all instances. Since I changed it once as a parameter, both of those values will change. And because I used a circular pattern, those diameters changed as well. So it really kind of maximizes the power of Fusion to make your designs quicker. So I'll come back in here. I know that was a distance. That was a distance from the center hole to the first hole. I'll hit enter. This one was also a distance from the first hole to the second hole. If you can think of better names, then please do that. Distance from the second hole to the edge of the flange. So now all of these, one more, this is just a number, so we'll go ahead and click that one. That's a diameter. It's not the center hole, it's not the hole in the flange, so I've got no variable for that. So we'll just go ahead and leave it as 6 inches. Come back here to our parameters. I'll add another parameter. Diameter, we'll just call it the big circle, for lack of a better word, and we'll put that at 5. And we'll hit OK. I can also not only put parameters in for my sketch, but I can also put parameters in for some of the functions, not only for the circular pattern here, but also for my extrude. So I'm going to add in a parameter for the number of flanges, and that's not going to be in inches, that's going to be no units. The number of flanges, I'll say 5, just so we can see a change. And I'm also going to put another parameter in here for thickness, and that's going to be the thickness of the material, and that's what I'm going to use to tell the Fusion how far to extrude it. So the parameters not only work in the sketch, but if I come back in here, double click that, for the number 3 right here, I can go ahead and type in number of flanges. When I hit enter, it goes back to 5 flanges. So I'll go ahead and stop sketch. And that's not what I was hoping to see. So we'll go back to our parameters. I bet you it's because when I selected the extrude, those patterns weren't there. Okay, so let me hit OK. Go back to my extrude. We'll edit that feature. We can see that those simply just weren't selected. So we'll grab that and that as well. trying to remember how to unselect that chunk of the flange. Can't remember how to do it off the top of my head. So I'll come in here to modify, change the parameters, and now for the number of flanges, I can take that back to 3. It goes back to 3 flanges. I can take it to 4, and that'll be 4 flanges. So I'm going to take it back up to 5. I'm going to have to go in here and fix that thing. So I'll pause it for a second while I fix that. Okay, so to fix that part, all I have to do is click it again. It took me a second to remember that that was the trick. If you select a piece of geometry that you don't want, if you select it a second time, it'll remove. So I can hit OK, and now I've got the flanges. So the great thing is I can come in here to the parameters, and I can just read these values right off of the PDF document. The 4.72, the 3, the 1.5 inch. I can just go ahead and read those off and put those in for all those values, the 4.732 and on down the line. And as I change the parameters, it changes the sketch and it'll change the extrusion as well. So we'll put that back to 3. The only thing I'm missing is that the thickness of my flange is too wide, or the width. Oop, I don't know if I've got that in there as well. Let me go back, look at my sketch. I wasn't down far enough. I need a parameter for this distance right here. So I'll create another one, and we'll call that flange width. And we'll make that a little bit smaller. We'll make that 2 inches, maybe 3. And we'll see what that does to things. So we'll make that flange width in inches, hit enter, and that makes it a little bit skinnier. So now when I stop my sketch, the circle part's still not showing up, so I'll go back to my extrude, include those, and hit OK. So now it's looking better. I can come in here to modify and do the fillet and select all those corners. And same thing, wherever I put a number into here, whatever that value is, 0.5, I can come back here. It's actually 1.5 inches for that. That's a diameter. So maybe we'll try 0.75. We'll see what it looks like. So I'll add another parameter. For the fillet radius. We'll see what 0.75 looks like. And OK. Same thing, I'm going to edit that feature. And instead of that number, I'll come in there for the fillet radius. Hit OK. And then we can go ahead and look at that. I think that looks good. So you can adjust all your parameters as need to, make this the proper dimensions, and you can really leverage the use of parameters to change your design in significant ways very quickly by simply adjusting these parameters. The next thing we'll take a look at, I'm going to go ahead and save this. Before I go any further, up until this point we've been working in the model workspace. Now we're going to come down here to the CAM workspace. This is computer-aided manufacturing. This is where we're going to set up our tool paths. First step in doing that is to create a new setup. And that's going to tell us our work coordinate system and what kind of material we have. We want our origin to be in the bottom corner. Since this is the x-axis and y-axis, I want to select this bottom corner. So this is the X and this is the Y. This is how the CNC router is set up, that the X-axis and the Y-axis is one of the corners of the material. Everything else we can leave the same. Come over here to stock. If I look at this from the side, you can see that there's a little bit of extra stock on top of my part. This is the flange we just made, and that extra part is there. So on the top offset, we want to make that 0. We want it to be the exact same height. And the post-process tab we can leave alone. It doesn't matter if they're side offset. That's not going to bother us. So I've got my setup. The first tool path we need to create is a pocket. It's going to be this center hole. So we're going to select a tool. Brings up a large menu. You come over here. I've already got some that I've used before. Click on the Samples tab. Scroll this all the way down to the very bottom, and then just scoot up a little bit to where it says Samples Tutorial Inch. And we're going to grab our 1/4 inch flat bit. It's not exactly the tool we have in the shop bot, but it's close enough. So we hit OK. Since we're cutting wood, we don't need any kind of liquid coolant. We can select Disabled. We're going to change the spindle speed to 10,000 RPM. And we're going to change the cutting feed rate to 120 inches per minute. And everything else will stay the same. Come over here to Geometry, and we want to grab that bottom part of the inside hole. So you may need to tilt your drawing a little bit, and that circle is what I want to use. So that's selected the pocket that we're going to make with our end mill. All of these you can leave the same. The heights will be the same. Passes, we can uncheck the stock to leave. We don't need to leave any of that. And then linking has got a little ramp angle. We're actually going to change this, but I'll show you what it's going to do if we don't change it. Let's come down here and hit OK. It'll take a second to generate the tool path. And you can see that red spiral as the bit comes down into the piece of wood. And if you look straight down from the top, it's going to come all the way down. It's going to do 2 circles to clear out that inside pocket. We do not need for the drill bit to go that slow and that shallow of an angle. So we will click Edit, come back over here to the linking, and instead of a 2-degree ramp angle, we can go 20 degrees. And you remember what the toolpath looked like before. When we hit OK now, it'll regenerate the toolpath. And now you can see it only takes a couple turns for the end mill to get down into the circle, and then it'll clear out that hole. So that is the first toolpath we're going to use. It's just a pocket. It'll turn all that to sawdust. The second toolpath we want to do is a drilling one. We're still here in the first setup. We're going to use the exact same bit. Leave the coolant disabled, 10,000 and 120. All those are fine. For geometry now, since it's drilling, we just can select those holes. The order that we select them in is the order that they will be drilled out. The CNC will just come in, plunge right into there, and select them. Right now the optimize order is checked, so it's going to do it the way it thinks it's fastest. If I uncheck that, it'll go back to the way that I selected them. But we'll go ahead and let them do the way that it thinks is smartest. You can leave the heights alone, and on the cycle, leave that alone as well. So it tells you that the router will go into this hole, slide across, drill that one, drill, 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 and drill. So we've got our center hole, those other holes. The last thing we need to do is cut this part out. So that'll be another 2D cut. That'll be a 2D contour. Same thing, the same 1/4 inch bit. Leave the coolant disabled, and the same speeds for everything. When we come over here to select geometry, we want to select this bottom edge, and it highlights it in blue, and it tells us which way the router will travel. We do want to leave some tabs on here so that our piece does not come loose in the CNC router. The tab width, we'll change that to 1/2 inch. The tab height, that's usually going to be about half the thickness of our material. So I think it depends whatever material you're cutting as far as what the tabs will be, but we'll set it at 0.25. And instead of distance, of having these tabs all over the place, I'm going to do them by position at specific points. So I'll do one on this side, and that side over there. And those will keep this part from coming loose from our bigger piece of stock. Passes, we can leave that alone. And then linking. Same thing, we want to ramp down in here again. We'll leave it at 2 degrees. I can go ahead and OK. It's calculating the toolpath. And you can see at 2 degrees, it goes in the whole way around this thing before it finally gets down to the blue line where it's at the depth we want it to. So that's just, if we were machining metal or steel, you might want a shallow angle like that. But for the wood that we're going to use, we can change it back to 20. I want to hit OK. It's going to generate the toolpath, and it did not change it. So let me go ahead. Ramp angle. So I'm going to change this maximum step down to 1 inch in addition to the angle. And now when I create the toolpath, if I come over here and look at the other corner, it just goes down at a 20-degree angle around the bit once and then back out. You can see the blue line is the path that the end of the tool will take. It goes up and then comes back down, so it'll leave a little section of material. Second thing we want to do is we want to see what this looks like. So we're going to come up here to the simulate function. You can either check the stock or uncheck the stock. We'll leave the stock on there so we can see what's going on. Right now it's set for the contour. I'm going to come up here and select the setup. Close out of here. Select the setup and then the simulate. So it's going to do all 3 of these functions in order. So we'll scoot that out of the way. You can speed it up or slow it down. But it does the center. It's going to drill. And you can kind of see it actually leaves the material out, and then when it cuts through, that's what the router is going to do to our section of wood. And the reason for these tabs in here is that we have to screw this piece of stock down to the CNC table. And if our screws are in this piece, or this piece, or this piece, or this piece, when the router cuts those loose, this center piece is not going to be held down at all, and it's going to vibrate around and won't make a good cut and maybe fly out and break. So the tabs keep this attached to the other pieces, and then we can simply pull this off the table, cut those, and make it a little bit easier to deal with. The last thing we need to do after the simulation is the post-process. So I'm going to come up here, same thing to my setup. If you're on any one of these, it will just process those individual tool paths, but we want to process all of them. So the post-process right here. All you need to do is select the Open ShopBot post-processor. And then we're going to go ahead and hit Post. And this is going to save all those tool paths in a way that the CNC router can understand. So I'm just going to click Decrypts. I'm going to save this to my folder. I'm going to name this Flange to CNC. And then this will save as a ShopBot file. So if I go into my tool folder, you can see Flange to CNC is a ShopBot file. The ShopBot can run that file and cut our flange. So I hope you have enjoyed this tutorial. If you have any questions, don't hesitate to ask. Thanks for your time.